So I'm going to present a functional pattern toolkit for a dataset, which was introduced in version 10. This is based on our work at the VA San Diego, and we're going to illustrate, and University of California of San Diego as well, and we're going to illustrate some of the methods with real data wherever possible, although it's kind of limited at this particular stage, okay? So we're studying how, in clinical situations, so in real hospitals, how computers are being used by doctors and how patients and doctors communicate with the medium of the computer in the room, okay? So that's a scenario. But really, what I want to show is that these methods kind of transcend the specific application areas here, okay? And we're also involved in IT redesign. And our studies have been going on for about 5 years now, and our support comes from a combination of National Institute of Health and also the Veterans Administration have a research office, and we're also involved with the VA in IT redesign. So in other words, like re-engineering health IT, okay, which I think is a really good opportunity for Wolfram to get inserted in there. Okay, so and by the way, so our studies, which have all been done with Mathematica as sort of like the centerpiece of the analytics part of it, have been ranked very, very highly by both NIH and VA, like literally like 1 or 2 percentile, which is, the funding levels have been going down and down, so that's a very good thing. Okay, so we use, primarily in the interest of budget and time, we're so constrained that we basically could not even afford a DBA, and we just decided to just put everything on the cloud. This is, this happened like in the past couple of years, so we were kind of rushed to do this. So we're using a collaborative, cloud-based approach to store all our data. Now, with respect to the previous talk, this is like small data. We're not putting up like an enterprise database. This is primarily just data that is being captured and we're analyzing it, okay? So it's not as if we have like data entry tasks or the need to be very granular in terms of like data entry. But nevertheless, so we're, the opportunity is that we can leverage the web file system. So we're using Google Drive, for example, to store all our data. So why not leverage the hierarchical file system that it's already been given to us? And web link data, of course, is part of that. And we're not using SQL at all, at least for my purposes. We also have to be open. I'm just one person doing analytics. We also have some of my colleagues are using R and Python, for example. So we have to collaborate. And we have multiple formats, but it's still really basic stuff, right? We have sensors that spit out CSV files, or then we can convert them to Google spreadsheets, which are co-editable, which is a gigantic leap forward. Everybody can simultaneously edit any piece, right? So this is a very agile approach. Something goes wrong, so like again, like instead of having a SQL schema, which is predefined, we really don't have time for that, and really things change as we go along, so that it's much faster to do it this way. Of course, you run into errors, you're gonna run into exceptions. We handle that at analysis time. And then one aspect of that is really, because we have to get everybody to understand the data, we have literally like coders, interns, people who don't understand data necessarily, who take a long time to explain, hey, well, you have to, they would either be caught up in the SQL situation where the SQL would not work for them, but instead we basically have to have something that kind of is both machine readable and human readable at the same time. Okay, so I want to stress that we're not doing any kind of big data. Everything fits on one machine. We're dealing with about 10 gigabytes of data from different sensors. The bulk of that data is time series type of things. So it's not like it's large, but it's the variety really that gets you, okay? So we're not doing anything in terms of like velocity. We're not dealing with bandwidth type of issues, okay? So keep in mind those types of limitations here. Some of our sensors come from, we deal with a variety of different data. So you can call it semi-structured. We have numeric data that would be like a natural thing in any kind of study. Text data, so it's like unstructured, patient record type of stuff. Like I said, time series from eye tracking, we have Kinect in the room. We try to see people's motions. So these are time motion studies, really. Okay. Okay, so Mathematica 10 really brought in lots of innovations in terms of like data analysis. Yeah, I've been working with Mathematica since version 2 for about 15, 20 years. And it's a struggle to handle multiple types of data and index them and so on, right? So just going from version 9 to version 10 has made a huge difference in terms of our code base. I basically like threw away most of the code application and API stuff that I did before in favor of the version 10 dataset support because it's just so much more compact. And if you have compact code, it's a lot easier to read, it's a lot easier to maintain, and you're constantly going to be adapting it anyway. Functional, meaning that you want to do as much stuff in line through compositions of queries, and query makes that possible. This is my personal belief that if you can avoid helper functions to any degree of it's not really possible 100% of the time, but if you can avoid it in a data analytics situation, you want to have the code to be as streamlined as possible so that you don't have any reference dependencies to get back and clean up. Like I said, it's not always possible, but to me, it's almost like if you can make the language become a scripting language, in a sense, you've gone a long way towards making your job easier. And so one of the main things is that rapid development is really, you can test the code on a small number or a subset of your data, right? Because you're going to be in an exploratory mode to begin with. There's tons of stuff to clean up. There's tons of normalization to do, even before you get to the statistics or data visualization or things like that. So you can test it in a very small set, and Dataset makes it very easy, as I'm going to show you, to then expand it to your full data set, okay? So that's one of the gigantic things. So some of the functions that are associated that came out in like number 10, in version 10, in addition to Dataset, really the association data structure is really like the heart of the system, let's say, because it doesn't look like much. It's almost like a key value list, but underlying it is a very sophisticated hash tree implementation of that. And then you have all these operators like merge and write composition. Composition was there in the language, I think, since version 1, but now you can kind of write from left to right and you just keep going, composing the language like that. Operator forms and name slots are also very big things. They make the language a lot more readable, basically. I think that if we can make operator forms for the entire language, you can make the language almost readable like a human language, in a sense, okay? Okay, so here's some examples, and these are just, I'm just giving it to you because we have Google spreadsheets, and they're really just like, on your local desktop, when you mount Google Drive, they're literally just like a couple of lines of JSON. It's just a URL, essentially, right? So you have to dereference the URL, and so we fetch all our data from online, okay? So Google's basically taking care of your synchronization for you, which is one of the aspects that databases are used for, so in a sense, we're cutting that out, that middle step there, okay? So these are just some utility functions to tell you that you can export a Google spreadsheet as a CSV, for example, okay? All right, now, so here's an example of some of the data that we have. None of it really fits on the screen, but so here's an example of a query. So we start with a data index, which is just a linear list of things. It's called visit data in this particular case. I wrote a function called key group by, which is the natural dual to group by. And I'll show it later, I think I have it. So you can see that you can sort of cut out a lot of the slot, actually numerical slot in this particular case. So this is a query. This entire query basically takes a long list of files, and then essentially this is the output. This is how it's actually structured. So what you see here is all the different types of sensors that we have. Okay, so you can see a combination of different things. EMR means electronic medical records. So these are human coders go through and they figure out what are the people actually typing on, what do they see on the screen based on video review. So you have a combination of multiple things. When you do scientific studies, you have to have multiple coders so you can do agreements type stuff. These are most of the times time series, so you have like synchronization parameters that are also handled in Google spreadsheets essentially. And this is the actual, these are just references to the data files. So each one of these data files will really be either a CSV file, so it would be, in SQL, it would be like a separate table for each one of these Q dots. These are just our identifiers. And we have hundreds of these. So you see about 100 per, that's about our sample size. So it's not really the sample size of the study. The unit of measurement of the study is like the visit, meaning the doctor and the patient are in the same room and you capture them for a while, for about a half an hour, let's say. So that would be like Q001, would be one patient, one doctor. But because you have all these multiple sensors, you can see the blow up is based really on that, okay? So even though it's something equals 100, it turns out it's about 10 gigabytes worth of data just because of this. Okay, so what I really want to emphasize is before this was a lot longer than 3 lines of code, okay? Okay, so again, like I mentioned, like you want to leverage cloud services wherever possible. Here's the example of key group by, which is, it's not a big deal. I just want to mention that by toolkit, I really mean that you can write a lot in just like 1 or 2 lines of code, okay? An operator, a form makes it easy to sort of like go left to right. Now, I'm not going to explain these pieces. It took me about a year or so to sort of figure out. And when I first started out, I was a C and C++ programmer, and you learn one way of dealing with code. took about 5 years of transition to start thinking in terms of like functional style and pattern matching. And once you do it like that, you can see the advantages. It's hard to go back, right? So this is functional style. So it's not as if you can't just know Mathematica coming from a different background and expect to understand this. There are even people in Stack Exchange who are like major experts and they find some of these queries hard to read. But with a little bit of practice, you can actually develop your own very quickly, okay? So here's an example of what you do. So key group by essentially, remember those Q files that I told you before? Each one is a visit. So here, there's no data. This is all metadata. This is just telling you what's grouped together by what. So here we have these are the doctors. So one doctor might have multiple visits. The number of visits varies. So here we group them together, and this is the query. This is it, including the visualization, the paneling, and grouping all these things together. And then further, you can iterate this. So not only are the visits grouped to the doctor, but the doctors then are grouped by, for example, specialty. Okay, so here you have a PCPs, a primary doctor, GIs, pulmonologists, and so on. Okay, we have multiple ways of grouping data. We also have by site, VA versus UCSD. There are different hospitals and so on. Okay, but again, to me, when you present this type of stuff to colleagues, is a lot easier to do than if you just have some flat table. It really is to have this kind of hierarchy. Okay, so your keys are really like the handles, and you're going beyond the SQL world, right? SQL is all about these relational tables that are two-dimensional. But as soon as you have keys, you introduce these new shapes, essentially, in your data. Now, here's a couple of variations. I'm not going to spend too much time on this because after I did this, I realized that there is a built-in key value apply that basically does similar to this, except that my handler gives you this key, so you don't have to write the key each time that you do this, all right? But not a big deal. It's just to show you the keys and value you can mix them together. Think of it as a 2x2 matrix. You have the inputs, the keys and values, and sometimes you need to combine them together, okay? And I'll show you some example of that. So these are, I want to stress, these are just one-liners that do a lot of work. Very reusable. Here's another one. You have a relational table, and you basically do a key pop. You take one of the primary keys, essentially, and you extract it out. Here's some examples. This is how you would do a normal relational table. And then you pop the key, and now the keys are essentially 1 and 2. They were like ID, basically, ID 1 and 2, right? And then you can reinsert it, key push, and now it's back in there, okay? So you can go back and forth between these two modes. Sometimes one is better than the other, and depends on the purpose. Okay, now here's my favorite one. I submitted this to the one-line competition. So this is a one-line recursive query that basically can de-serialize file lists. So let's say that, what do I have here? I think I submitted the entire thing. So let's say you have a file names given to you, and you can use whatever you want. I think I submitted just Google Drive. You want to index all of Google Drive, right? You get this flat list of paths. Okay, so once you split them apart by the path components, then essentially you can apply this tree, and this query then will give you a nested association where each of the path components becomes the prefix for that level of the association. Okay, so now I actually had an argument on Stack Exchange with the inventor of association, Leonid Schifrin, who thought that this would not really scale up, that this would not be a good way to actually create that deserialization. But some timing studies suggest that this is actually linear in the leaf count. So I think that really speaks to the efficiency of the underlying association. Okay, so this is the input, and this is the output. And it's normalized, so you don't actually see the data set formatting for this. But basically, you see that you have your root directory, Google Drive. So this is the key for one association, but then you have sub-associations. So now you can essentially like dereference just by typing in, tilde, Google Drive, whatever you want, or you can use all or spans and things of that nature, so you can go at this level. So what's the key advantage of this is that now you can see from one line, you can actually handle arbitrarily depth trees just with this one line of code. I find this really fascinating that this is possible. So let me just give you, so query actually works with any mathematical expression. However, it generates a temporary data set, okay, which is then it's thrown away, but in other words, there's an internal like types definition in data set, so there's a little bit of an overhead involved in that, but you can basically apply query to any expression. Okay. These are no big deal, just again, some more things to sort of say, like if you have an association and you just want to like tally things, of course you can use the built-in tally, and there's actually other functions that can kind of do similar things. But again, my point is that, I think of these things in my sleep. When I go jogging, I can think, because there's one line of code, you can kind of keep everything in memory. If this was a longer query, you can't do that. It becomes kind of, it's a chore to it becomes like a puzzle that you kind of have fun trying to solve. Normalized by, let's say you have a list, you have to branch off to find out what's the total for that numerical list, but then you want to normalize all the individual entries by that total. You sort of have to branch into these two steps, right? You have to sort of, so you can see like a nested query here. Here's the original, I could have put identity here, and then here's a particular function that the user passes, and then you have to merge them together. Now this is actually pretty bad. I found some easier ways to sort of using replace and pattern matching to put them back together. But again, this one particular function, you can apply it to any association. By the way, I have an API I'm just showing you about like 10, 20% of what's here, but they're all about like 1 or 2 lines of code each one, okay? Okay, so here's one that's a little bit more sophisticated. Quantile association. You have an association, and then you want to essentially group them to where they are in the statistics. Are you in the top 20%? Are you in the bottom 20% of the entire association? So this is basically it. So you have, well, of course, this is a little bit more work just because of the way that quantiles work. There are intervals and so on, right? So you have a function here to, you notice, by the way, like every time that you have 2 separate input arguments here, you have, this is operator form, essentially. It operates on this, but this becomes the parameter, essentially, the quantile. So you can change the parameter, the quantile steps, essentially. So here's an example of how it would operate. We have this data, and this is the NASA, this is called the NASA TLX. It's basically like how stressed are you during the visit. It's a workflow type of survey. So these doctors fill in these surveys, and of course, here they've been to quantiles, and then we color them according to where they are. So I think blue, they're in the bottom quartile. Gray is like the center, like 50%, and then the blue or red are like the top 20%. Those are all just parameters you can change. And what this shows you is very quickly, I was able to convince my colleagues that look at this, Dr. 07, regardless of the patients will be 1 row. Each patient will be 1 row, and then each item of the TLX survey is a column. And just by showing you this, you can see that Dr. 07 is never stressed. Every visit, every item is either normal or below stress level. Whereas if you have some other doctors like Dr. 10, gastroenterology, pretty much every visit they're stressed about something, right? Now what I'm saying is like this is a very complex and efficient way to communicate with people, this graphical language. Now underlying this are numbers, right? But what I'm saying is like just one extra step later, you can convert these numbers to something. But again, these are all keyed. So you have the keys that are already available to you. There's no point, you don't add them later. Basically you have to like, in version 9, you have to kind of like fetch all the keys and put them together. Here they're already there. The functional aspect is you're just manipulating the values. The keys are invariant. Okay, so they're already grouped, for example. Okay, so that's an advantage of doing this kind of stuff. And people didn't know about this stuff before. They thought, let's just use the TLX scores raw. No, you have to center them by the individual doctor, okay? So very nice way to communicate results. Yeah, okay, here's another version of this. This is probably lamer than the previous version, but this is the standard data set formatting. So you can see here, you can just rescale basically like a word cloud type of situation, but you can build these dashboards very quickly. Each one of these are items and so on. I don't want to take too much time, but again, it's the fact that functionally you're just affecting the values, but all the keys are already synchronized. Okay, this is 11 out of 14 files. Here's one that's a little bit more involved. So, a lot of stuff is baby steps, but when you get into time series analysis, that becomes a lot more complicated because now you got synchronization issues. The timestamps are not necessarily reliable. You got to convert them into intervals of time values and so on. But here's an example where, based on the clickstream analysis, we combined the mouse activity, which is human coded based on videos, with the keyboard activity, and I think that's about it here. And what I want to stress, what's functional about this? This is the query. And what's functional about it is that I'm not telling the system the coordinates of where to put things. Okay, I rely a lot on things like row, column, grid, and these types of, which don't have parameters. If you were to inset things into a graphic, then you have to specify coordinates. But the coordinates might change. You have to, there's new things that you have to insert. So from a functional point of view, I just let Mathematica do as much of the work as possible. Like that TLX, I don't specify exactly where to put it. And if you do like a screen resize, everything is pretty much elastic. Okay, so I think that's another aspect of the functional approach. So just to show off, we can tag pretty much like all the activity that happens We can do time at task analysis. So all these timestamps, they're not the raw timestamps that the sensors give you. These are like the duration of how long did it take somebody to enter a medication entry through a computer, for example. Well, again, you have time objects, and you just subtract the time objects. You have a little bit of scaling to do in terms of time. But again, very, very quick compared to version 9. Version 9 to handle time series was a monster. And now it's like really, really approachable. So this gives you a combination of, these are like not that it's a big deal, but basically like the black are like the keystrokes and the white frames are like the mouse activity. So basically from this, we were able to show, even though all the data is masked, that doctors always enter manually some numbers that are already in the computer. And we were very interested in this issue of like, this data is redundant then, the workflow is redundant. You're fetching some data that's already in the computer, why are you typing it in again? So we were able to show through this clickstream analysis that they're looking on one screen, reading some information on the screen, and then typing it in, which can cause problems, but in any case, it's inefficient, okay? So these tools, again, like most of my colleagues are either medical doctors or people without a lot of like data background, and if I were just to give them some either raw statistics or some kind of like tables, it just never works. It's not really convincing. This stuff is basically the raw data. And by the way, like when I forward this stuff to my colleagues at the VA, they pretty much give it to their superiors and they say like, hey, here's these guys in San Diego who know what they're doing. And I can't tell them what tools I use and everything, but it's really not me. It's just the tools themselves that make it a lot easier to do this sort of stuff. Okay, so just please keep in mind, these are just like a few lines of code each, okay, starting from the raw data almost. Okay, I think I did this one. Oh, wrong, sorry. All right, this is one of I'm doing my own project here just to show you that you can take, you have a bunch of data here, like in this case, I wanted to do this visualization just to show that the timeline plot right now doesn't really have a layout engine. So the labels all kind of clash if you have too many labels. So I just wanted to do something that kind of spreads out the labels when they're too close together, for example, over here, okay? So this is just, you just add a parameter and you try to space them out as much as possible. But this is it. This is basically from the raw data, this to this. Okay, and I think I can actually get it even shorter. I built this maybe like a year ago. I'm still learning the system, and every time I can get it like 10% smaller, and so on, all right? So yeah, so I'm very close to the end here. Okay, so I just wanted to talk about future need. Unfortunately, I can't talk about every function that we build, and we constantly build new ones anyway, right? But I just wanted to say, so Dataset is a tremendous tool. What I wish is, I do a lot of like exploratory stuff where I need to know the shape of the data, basically, right after we index it, let's say, and find out any kind of exceptions and so on. What I would really like to have is some sort of tool that lets you do that momentarily. So like, let's say I want to, Mathematica already has openers that you can open and close. But I don't want to like program that into like every data set. So I would like to have some sort of remote control where basically, you have a key, like a touch screen, let's say, and you just open it, basically momentarily like open up that key and you see the values. And then when you release it, it just goes back to just the key. Okay, so now these tools are available. This is from Apple Logic Pro, which is an audio tool. Basically, the iPad is the remote control. So you see, of course, it's still, you can still read the sliders and so on, but you're actually manipulating what's going on the main screen, which is the Mac here. And I think something similar could be done for Dataset, because I really spend, I don't know, 30, 40% of my time just figuring out where the data is and where the branch, how does it branch out, and where can I merge things, and where are the missing values, what can be like thrown out, and so on. Okay, so a tool like that would make it much more real time, rather than right now what I do is, I'll type in the query, but then I have to delete the query because I wasn't really interested in that. I just want to explore the data. Okay. All right. So then we need functional interoperability, or at least it would be nice with cloud apps, not only just Google. For example, right now we can read from Google and we can write to Google spreadsheets, but we can't write to like a specific cell or a range of cells, right? But those tools are coming, like Smartsheet. That you can embed URL, so you basically have a version of like linked data just from using spreadsheets. Right, so I think that we can, if we can improve interoperability with this, the days of SQL are pretty much gone, because you can do everything inside of here. And then I just wanted to say that we were trying to install Mathematica on the VA networks. They told us no at the local level anyway, because there's all sorts of, you can see this is just like a fraction of the types of security measures that we have to like abide by. And if we can, the data security and data privacy, they're two separate issues, but they're sort of related. If we can handle that, I think that might be a way where Mathematica can actually be run on the V8 network. So you need things like secure storage. The data, when it's stored, has to be encrypted. They already have encryption, but they don't trust it, so you have to have these extra layers on top. Now, when I import it, I don't want to constantly do that and encrypt, decrypt. So key management, authentication, and those types of things, if they can be, the more transparent you can make them, if you can make them like one function, as per the Wolfram philosophy to integrate everything, could potentially get over these types of hurdles. And I believe that's it for now.